Hello and welcome to another Tell Me Why. I'm really excited about this one. We have Brett and me, two separate meteorologists combined to bring all of our years of meteorological training to answer all of your fantastic questions. You've had a chance to see some of the questions that were going to be answered asked.
Right.
I have not had that chance yet. So before we get into your career, how do you feel about some of the questions that these amazing kids have asked us?
Oh, I think they're great. I think they're wonderful weather questions, and it's honestly questions I've heard before, and I certainly love to answer.
Good deal, and you're so good at this. You probably recognize me as being the guy who did what he did for many, many years. I still always keep my eye on the weather. I'm not a practicing meteorologist, but I am still a meteorologist. So, and it's good to have guys that smart in this part of the country. No joke whatsoever, because as we all know, we are in the middle of what is called Tornado Alley, which is one of the questions that we're going to be answering. All right, let's talk a little bit about you, Brett, your career, why you got into meteorology and television, and where you hope to go.
Well, I basically, I've always loved the weather ever since I was a kid, and I grew up just south of Joplin in northwest Arkansas, so I've experienced my fair share of the weather that happens in Tornado Alley, of course. And basically, I used to be insanely afraid of tornadoes and severe weather, but that inspired me to learn more about it. I went to the University of Oklahoma and got to chase tornadoes, got to learn a lot about meteorology and all the math that goes into it too. And then I was able to get this job right out of college, and I've been here since. That
math that comes with the meteorology, if I remember, it was, what was the name of the class? The class that I took, it was thermodynamic meteorology.
Yeah.
It hurt me.
So
it's a lot of math, and it hurt.
I took 4 semesters of calculus. That's calculus 1, 2, 3, and then physical mathematics. Meteorology consists of things like partial differential equations, atmospheric dynamics that basically have equations so long that are the primitive equations that govern the atmosphere that essentially would fill up the entire length of this monitor behind us. Atmospheric thermodynamics, it keeps going. Cloud physics, radar meteorology, mesoscale, synoptic,
climatology, it's all in there, and believe it or not, all of that stuff is absolutely essential in being able to detect what's happening in the atmosphere and why what's happening in the atmosphere is going to affect what's going to happen at the surface and in the future, and that's what forecasting is all about.
Of course, all of these things come into play, especially when it comes to numerical weather prediction and computer models and all of that great stuff.
All right, and I'm going to throw one more fun fact in, at least I think it's fun. All of this information that Brett uses and other meteorologists use, it's all acquired through balloons. I know that's a crazy thought in this year, this advanced year, but all of that basic information, they launch balloons. Every National Weather Service office in the entire country launches them, so you can get a good snapshot of the moisture in the atmosphere, the wind speed in the atmosphere, if there is wind shear, and that's something we'll get into later on in the show. All of this stuff needs to be known and tracked so that you can put that numerical forecast together, and so Brett can bring it to you every night on the evening news.
Right, and maybe in the future we'll display one of those graphics that they output and explain it, because they are on the complex side, but very, very useful.
Okay, all right, you ready to go?
Yeah.
Ready to answer our first question? Who do we have?
My name is Ryder, and my question is, how did Tornado Alley become a place with so many tornadoes?
Ryder, fantastic question, and this is a rare opportunity to find out how good of an artist Brett is. Because
Terrible.
don't tell them ahead of time, let them decide.
Yeah.
So what are you going to draw for us so we can answer Ryder's question?
Right, so I'm gonna basically draw the setup, the geographical setup of the central United States that defines Tornado Alley. There are actually two different areas in the United States. One is called Tornado Alley, which consists of us and the Great Plains of the United States, but there's also Dixie Alley, which is the southeast United States, which also sees quite a bit of tornadoes.
That's right. In fact, I believe the United States is the country in the entire world that sees more tornadoes than any other country on the planet. So if that's good or that's bad, well, it's bad. So we're going to find out where Tornado Alley is, and then Brett's going to explain why it's Tornado Alley.
Yeah, so Gary, if you hold this for me, I'll
Happily.
start my wonderful artistic
All
skills. So I'll start over here. So first it starts off with the Rocky Mountains. And I'll just draw these triangles. These are the Rocky Mountains.
I would have known that a mile away.
So this area here will be the Great Plains.
Okay.
And of course we'll do a little star here. Call that Joplin.
Okay, that's Joplin.
Yeah, so down here is going to be the Gulf of Mexico. And then,
hey, this is pretty good. You can see, you know, it's almost like a photograph.
So the basic setup is what creates or helps to create the perfect situation for tornadoes is what we call SLIM, shear, lift, instability, and moisture. So what happens is you get large scale waves that will come over the Rocky Mountains.
Okay, explain what you mean by waves.
So take a look at this map behind us. This water vapor imagery. And Gary, if you want to keep holding this, I'll step over here and just illustrate what I'm talking about. So this is aloft in the atmosphere. These
Meaning
large,
high up.
way up in the atmosphere, you have dips in pressure that occur, and this essentially creates a dip in not just pressure, but also an amplification of the jet stream, which is very fast winds aloft. Now, when these waves go over the Rocky Mountains, you get a very complex process, and I'll just say what it is, but we won't go into the specifics of what it's called, but it's called Lee cyclogenesis.
Yes, it is.
Yes.
And if you break that down and maybe even go back to the Bible, Genesis means the beginning of
Of course, yes. It means the beginning, creation. So cyclone is those areas of low pressure. So if we draw an L, when these waves come over the Rockies, you get the formation of, when you see them on my maps, the L at the surface.
That's the low.
Yes, so you have a deepening of low pressure, an L, low pressure in the northern hemisphere. We also call those cyclones. So the cyclo of cyclogenesis, so the birth of a cyclone occurs in the lee of the Rocky
Which
Mountains.
is the east part, at least in the northern hemisphere, that is the eastern part of the eastern fringes of where the Rockies are.
Right, and when you get the formation of these, you get usually winds that will come up from the Gulf of Mexico, and then you will also start to get the formation of fronts, which usually you have cold fronts that extend along the southern edge of those low pressure systems. And with the winds coming up from the Gulf of Mexico, this brings you moisture. So the M in SLIM, the cold front is the L in SLIM, the lift. So you have the L from SLIM.
L normally on a map means a low pressure system, but using that particular SLIM, this means lift. And you might be wondering why lift is part of this. So explain the process of lifting a parcel of air in the atmosphere.
So in order for basically, think of it as a box of air, a cube that has to ascend. And as it ascends, it also is going to cool, and then it is going to condensate all of the water it holds within it, forming a cloud. And then once those clouds continue to form, then you generally get the formation of rain and thunderstorms, etc. It is essentially, you need a lifting mechanism, like a front, in order to take that cube and throw it up into the air to form thunderstorms. And that is a key process in the formation of tornadoes, because you can't have a tornado without a thunderstorm.
And the condensation that you were talking about, same thing when you take a can of soda outside in the summertime. All that stuff on the outside, it's condensation, and that's essentially part of what clouds are and the moisture in our atmosphere.
And so you have the M with SLIM, the moisture here coming from the Gulf of Mexico. This is very specific to the United States. You have to have the Gulf of Mexico, and you also have to have the Rocky Mountains. And so the S, the shear, comes from those winds aloft with this system. And
again, aloft means
very high up in the atmosphere.
Almost in space, just below space.
Right, so you have several layers to the atmosphere, and way up high in the atmosphere, like I just showed you on the map behind us, is very strong winds provide that shear. And all shear is a change in wind direction and speed with height. And this, in combination with a cold front that provides lift, in combination with the moisture that comes from the Gulf of Mexico, and also another feature called instability, which is basically the energy storms are able to use to become more intense, you then are able to form tornadoes. And this setup basically allows for the greatest potential around the world to see tornadoes in Tornado Alley.
And I know that sounds very, very complicated, and the process is complicated. The one thing that differentiates tornadic storms from the other types of severe weather has to do with the shear. And what that does is it creates what are known as solenoids of air in the atmosphere that end up lifting and then bending over, and then it turns into what we are very familiar with, unfortunately, as tornadic activity. And those things are what radar looks for, so that Brett can warn everybody ahead of time that there may be the potential for air coming at you like that. And that's where the whole tornado idea comes from.
Yeah, so think of a tornado as an area of an area of low pressure, just very, very small and very, very fast. Because as winds and basically areas of rotation get smaller and smaller, it's a conserved quantity, so it means that nothing is removed from it. So it means the winds are going to spin faster, and the system is going to amplify, and you're going to get basically a faster and more powerful system because of it. Now, when it comes to tornadoes and actually looking for the possibility of one being developed from a thunderstorm at the base of a supercell, now it has to be a supercell generally.
And define what makes a supercell.
A supercell is a storm that has a rotating updraft, and this can generate a lot of large hail, and it produces a tornado as an extension of the rotating updraft to the ground. But it has to take in a lot of basically spin in the lower atmosphere and turn it right side up, and then into the base of what we call the mesocyclone, which is the base of that rotating updraft, and then a tornado is then an extension of that.
And the way that you find out that that potential is there is by looking at Doppler radar. Doppler radar was a huge advance in meteorology when it was discovered and put into place decades ago, but I firmly remember the time when we didn't have Doppler radar. We have that now, and it determines where wind is coming from one direction and then coming from another direction very close by, and that's what creates the spin.
Right.
And if we didn't have Doppler radar, we wouldn't know about that spin.
So you can also, you shouldn't be outside if there's a tornado warning, but if you are looking at a supercell thunderstorm and you look at the base of it, you can look for a feature which is called the Bear's Cage, which I'll go ahead and draw a little diagram here. So here is the base of your supercell, and here's the ground, and this is the ground. So usually your Bear's Cage will be an area that is shrouded by rainfall, and it is basically where the tornado is likely to occur. But you also will have what's called a tail cloud extending from this, which is all of that spin, which is horizontal in nature, that is being pulled into the base, and then it is turned vertically. And then you get the extension of this down to the surface, and then the formation of a tornado.
That's right. So there's a bending going on. There is horizontal shear and spin. There's vertical shear and spin.
Yes.
All of these things combined. It's very, very complicated, but he knows how it all works, and he's got all the cool tools to be able to see where it is, and more importantly, or as importantly, where it's going.
Exactly.
Hope that answered your question.
Hi, my name is Kinsley. I'm 10 years old, and my question is, why does thunder make sound?
Kinsley, obviously into the sounds of storms, not the sounds of silence, the sounds of storms.
Yeah.
She wants to know why thunder makes noise. And it's not just because it wants attention.
Yeah, that's true, but lightning does.
Lightning does
Yeah,
want
because it flashes and then it also generates sound. And thunder is a direct result of lightning. So, lightning is insane, okay? It's 5 times hotter than the surface of the sun. So, it being that hot, it goes, and of course when it occurs, it goes through air. So it superheats the air, which it heats it up a lot. So it really makes it hot. And when
Fast.
Yeah, lightning is so fast too that when it disappears, it creates a vacuum. So all that air is going to immediately go in to where the lightning was, and that generates a crack. And that's thunder. And so thunder can travel 10 miles from where lightning has occurred before the sound is dissipated. So if you see lightning and you don't hear thunder, then it's obviously over 10 miles away. And you can actually count, basically when you see lightning and start counting. So if you go 1, 2, 3, 4, 5, and then you hear thunder, divide that number by 5, and that lightning would be 1 mile away.
And if you hear thunder or see lightning when you're outside, don't be outside.
Yeah.
That's a
Yeah.
really good idea.
When thunder roars, go indoors. Don't be the tallest thing in an area. Don't be near metal objects. Don't be in water, because all those things are conductive of electricity. And that does include human beings, because we are 70% water.
Exactly. And so well put. And I might mention that I have less of a chance of getting hit by lightning than Brett does.
Yeah,
because
if we were in an open
see,
field, yeah.
I'm good to go. He needs to be down.
I'll just hand you a metal umbrella and then we'll
Thanks
change
so
the odds.
much. Yeah. And I think that brings up another good point. If you do see lightning, hear thunder, try to get as low as you can.
Right.
That's the way to stay safe. Hopefully you're not in a situation where you're out in the middle of the storm in the first place, because if you're watching Brett, he will tell you when those things are coming your way.
Very
It's
true.
important to know. All right. That was a good one, wasn't
Yeah,
it?
it was. Yeah, it was a really good question.
All right. I bet we got more good questions.
Hi, my name is Gideon, and I'm 10 years old, and my question is, why does rain fall?
Gideon, that is an excellent question, and he's obviously very aware of what's going
Yeah.
on, because if he's outside, he notices that rain doesn't just hang in the air.
Nope.
No, it does not do that. It will actually fall.
Yeah.
Why?
And it will fall until it doesn't. So, thunderstorms, let's use thunderstorms as a base here. So, to begin, dust particles form cloud particles, and then cloud is essentially condensating, and then you have condensation that forms water droplets, which also have the nucleus, which is the center of them, which is what they are based off of, which is what attracts water vapor that is usually dust. And so you get the formation of water droplets in a cloud. But because of the intensity of the thunderstorm, it will suspend those cloud droplets and also those water droplets.
And is that because of updraft?
Yes.
Yes.
Until they are no longer able to be basically upheld by the wind. Similar process with hail. Then they will begin to fall because of gravity. And as they fall, you will have they will collide with each other. That will generally form larger droplets, and they will coalesce. It is a process called collision coalescence, where as the droplets fall, they collide with each other, and then they also coalesce with each other, which forms larger droplets. And usually the stronger your storm is, and also based on factors such as precipitable water, which is the vertical column of the atmosphere, how much moisture is able to be precipitated out by thunderstorms, you can get heavier rain. But basically, in a much more simpler way, gravity and also the inability for the storm's updraft to uphold the droplets anymore causes rain to fall.
And Can I just piggyback on
Yeah.
top of that for just a second? Because I think our producer's going, maybe not, because my piggybacks tend to go a long time. It'll be quick though. But he mentioned that the nucleus of these raindrops are very frequently a small particle of dust.
Yes.
Inside every piece of hail is also a nucleus that
Yeah.
can be an insect or a small particle of dust. How does a rainstorm produce hail?
So first off, you have to have strong thunderstorms generally.
Right.
You also have to have cool temperatures aloft. When the updraft launches basically the water droplets into the upper parts of the thunderstorm, you also have ice particles. And you also
It's
have
really cold up there.
Oh yeah, you have the formation of ice particles aloft within the thunderstorm that are going to encounter what's called supercooled water, which is water that is liquid that exists below the freezing point. So as soon as it touches that ice particle, it is going to freeze to it. Now you can have wet and dry hail, but you can also see this with hailstones. The larger hailstones, they fall within the thunderstorm and then they get thrown back up by the updraft, collect more of that water, fall again,
It's
go
like
back.
a snowball effect, right?
Yes.
They get bigger and bigger when they go up and down and up and down. And sometimes they can do that multiple times.
Oh yeah, and it creates a larger hailstone. In fact, one of the heaviest hailstones fell in Coffeyville, Kansas. It was massive. It's like this.
Yeah.
If you look on their website, their city's website, you can actually see a picture of a remake of it. And what you can also do, and you should never go out during a hailstorm, but after a hailstorm, if you pick up a hailstone, you cut it in half, it will have rings, and you can basically count how many times that hailstone has gone up and down inside a thunderstorm.
Isn't that fascinating? And I always found it interesting in meteorology school that the tiniest thing can be the nucleus
Yes.
of hail, including insects, little tiny little insect, maybe even half of an insect.
Generally dust,
Baby insect.
usually, but you can also, like acid rain comes from basically a form of pollutant that is used as the nucleus for those cloud droplets and those water droplets. You can also get black rains that come from volcanic ash because those are used as the nucleus. And you can also get pyrocumulus clouds, which are storms formed from volcanic ash that are created because the ash is used as the nucleus for the cloud particle.
Okay, I gotta say, I'm a meteorologist, have been for a long time. I just learned some stuff by watching Tell Me Why. Brett, it's been wonderful. Thank you so much.
Yeah, it's been
I
fun.
love watching you work.
Thank you.
This guy knows his stuff. If you want to know what's happening with weather, tune him in because he will be absolutely right on top of it. Appreciate it. Thanks for being part of Tell Me Why.
Yeah.
And we've got so many of these that's available to you, all kinds of different subjects. So keep watching because we love it. Bye.